We're going to do the magnesium CO2 sandwich. This is one of the few reactions in which carbon dioxide actually acts as an oxidant, i.e. it promotes a fire and propagates it rather than putting it out. Dave's demonstrating how to prepare the CO2 blocks for the experiment. It's important that the edges are smooth facing as they possibly can be. You've got a large surface area of CO2, so be aware of any areas of bare skin because you will get burnt. So a nice circular motion, and if you do that with both blocks until you can sort of see that they're relatively smooth, and test mate them together once or twice to make sure they're as smooth fitting as they can possibly be. A good point to note at the beginning of the experiment is that the blocks of CO2 are completely opaque. First and foremost, we're going to drill a pilot hole, and we're going to use that to guide our tank cutter in, which will drill a cylindrical hole, and once the tank cutter guideline's been drawn in, we'll use an ice pick to smash up the CO2 within it and take it out as the particles are formed. So, our blocks are now prepared, and it's time to add the fuel in the form of magnesium turnings. You put sufficient magnesium turnings to about 3/4 fill the indentation. You need to keep the level just below the upper edge of the indentation. This cuts down on the amount of magnesium that comes spitting out when the flame starts. Okay? Then put the magnesium well away from the reaction. If the reaction does get out of control, you'll need a fire blanket and, on standby, a CO2 cylinder. The fire extinguisher should be used for any secondary fires, not for the primary fire, which should just be covered up until it burns itself out. Before we start the experiment, to get maximum effect, we turn out the lights. Wait for it, wait for it, wait for it. Okay, go, Dave, go, go, go. Step back, step back, step back. The whole point of the experiment is that the magnesium uses up all the oxygen in the block and therefore starts reducing the carbon dioxide. Notice how exceptionally bright the magnesium is. You might recall how opaque it was before the experiment. That means there must be an intensely bright light inside those blocks. This is why magnesium is used in magnesium flares and Vary lights. So the reaction's coming to a rest now, and we're just waiting for the magnesium to calm down a bit, and we're going to take the top block off. So I'm just going to ask Dave to lift the block off rather than sliding it. And we've got a black ball of carbon, and adorning its surface is a nice sprinkling of icing sugar like magnesium nitride and magnesium oxide from aerial oxidation of the magnesium. But very clearly you can see that black mass of carbon, which is CO2 that's been reduced by the magnesium.